Unfortunately, the main theorem of the proof was flawed, so I still have some work to do. So.
I don't recall the theorem exactly, but it's something about Pythagoras' theorem, right? Or can you explain the Fermat's last theorem?
Yeah, it's very easy to state the problem, actually. It's a Pythagoras theorem, a squared plus b squared equals c squared, but then to change the exponent to, instead of 2, we have 3, 4, or 5, whatever. So, and the theorem, the margin note of Pierre de Fermat was, I have a wonderful proof that the case is that there are no solutions in whole numbers when the exponent is 3 and above. And he said that the margin is too small to allow me to write the proof.
I wrote it in a margin or something, right?
Yeah. He had a book about a Greek mathematician, Diophantus, which is about whole number theory and whole number equations. And on the chapter about the cubic equation, this note was, he left this note in this book. And actually, when Fermat died, he had like 30 different type of problems that he stated that he had proven. Also with this type of probable margin notes. And then the mathematicians, they have struggled for like 350 years to prove this. And then there was one left. It is called Fermat's last theorem. And it was proved by Andrew Wiles in 1994. And the proof of Andrew Wiles is like 800 pages. And at the time, there was maybe 10 mathematicians in the world who could understand what he'd actually done. And in order to prove this theorem, he proved something else called Taniyama-Shimura's conjecture. And Fermat's theorem ended up as a corollary from this result. So since then, about 1995, I read an article about this problem, and I said, well, probably there might be a much easier solution to this problem. And I started to work with it, and I found some non-trivial results that resulting in that I was accepted as a PhD student in mathematics based on my results. If my results were unknown, I would probably be doctorate in mathematics. But unfortunately, they ended up, as I found them in Paulo Riebenboim's book, 13 Lectures on Fermat's Last Theorem. So, and I've been working with this problem ever since, and I have had a flash of inspiration this Christmas. So, during the mellandagen, or whatever that's in English, Christmas days, I found a probable a way using number theory in a different way to simplify the problem. Again, finding a mathematical structure that matches your problem. If you do that, you have basically solved the problem because you can use all the results about this mathematical structure to find your result. And this was actually what Albert Einstein did when he struggled with merging special relativity or relativity theory with gravitation, and he was lucky because there was a mathematical structure already from Riemann. Non-Euclidean geometry, off the shelf, accessible with curved space and everything. So he just took his equation and within this mathematical framework, and he can show that gravitation actually bends space-time. So
applied some existing theory that did exist.
Yeah, so it was it was plug and play for him. So
and now what amazed you? So now you basically tested your theorem or your angles and ideas in Claude. Specifically now, what amazed you? Not just interesting, but this was cool.
That it appeared to know mathematics, but it actually doesn't. It's a parroting of a lot of humans' articles, but it does it in an amazing way. So it was actually very useful. So instead of asking one of my mathematician's friends to check the proof, Claude did the job, and it did excellent work.
Did you put the previous proof, or did it more work with the theories that you had? So
no. I have a much simpler approach. So basically, elementary algebra, some group theory, and that's it. So the proof, which turned out not to work, is about 10 pages. And I think there might be a way to fix it, but I have to wait till next Christmas.
So the shortcut here is like inspired by the Einstein anecdote, is to find the systemic architecture of math, and all of a sudden you're applying that, and then actually you can prove two things fitting together.
Exactly. And it's the same approach when we have crafted this artificial general intelligence architecture. So if you look at today's AI and the mathematics behind it, it kills the structure in the information. If you do Fourier analysis or synth programming, if I say, hello, how are you? I get this sound file. I can use 10,000 voices with different settings, volume, frequency, phase, and I can have this system say, hello, how are you? And if you look at the different parameters, they are sine waves with virtually no information in them. So this is an analogy to how today's AI works. It's a lot of parameters. It's a big black box. If you just have a big enough parameter space, you can fit any data to the model can replicate virtually any in data. But the structure of the information is lost. You have an implicit mathematical model. So ideally what you would like to have is a different type of mathematical model with a richer mathematical representation that's more structure preserving than today's AI. And this is what we have in our model. And this is the reason why we believe that we will have AGI in 12 months.
Wow, what a setup, huh?
Yeah. Oh, I'm so tempted to go into the rabbit hole already.
Let's introduce the guest and set up the theme. I think it's the perfect setup.
Yeah, awesome. So very welcome here, Karim.
Thank you very much.
Nouira, is that?
Yeah, very good pronunciation. Thank you very much. I really appreciate to be here. I look forward to this since I spoke with Laura last year. So,
but you're a founder and CEO of Superintelligence Computing Systems. Is that right?
Yeah, right. Yeah.
Super cool. And congrats on the progress you have seen there. I'm really looking forward to hearing more.
Yeah, thank you very much.
What you're working with there, but you mentioned that you started to do a PhD as well in mathematics. So we already heard that you have some interest there and a lot of knowledge there. So I hope we can really have a fun and interesting discussion here, going deep into both AI and math in some way and form.
Yeah, and we always try to find a theme for the podcast, and the simple theme is the future of AGI. So it's going to be one of those conversations which can be philosophical, but I would love to make it mathematical. Not because I can follow, but I would like to hear that angle on it, and the architectural, the JEPA paper, and all this. So we have so much to paint on the canvas for the future of AGI. So
yeah, I mean, let's not be too afraid about going a bit technical as well, or mathematical sometimes.
No, I think it's about him protecting his IP.
Yeah, right. We'll have to drag it out.
We will drag it out.
We'll see what happens if I happen to say something I shouldn't.
We've had people who are, representing Microsoft with insights on OpenAI's roadmap, and we've been trying to drag it out, and we've been trying to, no one mentioned, no one forgotten. You know what I'm talking about.
But I think when Anton was here before Lovable, he'd mentioned a lot there, so I think we dragged this up.
Yeah, we had Anton Osika here the month before they did the Lovable proper launch. Cool. It was a project before with a different name. Yeah. And we had him here and then it just took off. So, cool. So we have some more beer.
No, but Karim,
drink water, thanks.
Perhaps you can just very, very briefly describe a bit who you are, your background, and how you ended up at the Superintelligence Computing System.
Yeah, sure. So I'm a jazz musician. I played together with James Bradley Jr., who is one of the best drummers in the world. I used to tour with Anita Baker and Lenny Kravitz.
There's a side note here. We have a non-statistical survey going on. How many musicians there are there in AI? Yeah. And it's actually, it is almost statistically valid by this point.
Yeah, I'm the exception, I think.
You're the exception because
not too late.
No, because
I don't have no talent in music, so.
No, but it's like, it's surprising when you have a conversation like that and a couple of beers afterwards and we start talking about life and music comes up all the time.
Yeah, music is a vital part of life, and it's probably connected with life in a way that in a metaphysical way that we probably don't really understand.
Yeah, and what do you play then? Which instruments are your?
I played the Fender Rhodes keys, piano. Yeah.
Oh,
yeah. That's
damn
nice.
it!
Yeah.
We had the keyboard here before. I should have had it. That's shit. You need a proper.
Okay,
Rhodes.
but musical background then. And are you still active somehow? Or?
Yeah. Now the company takes a lot of time, but after my last exit, I played a lot in clubs. Strandvägen 1, Lydmar,
Really?
Nefertiti in Gothenburg.
Jesus, impressive. I'm getting very interested here. Okay, but please explain. You started your career, I guess, in the studies as well, in math, right? Or how did you get started with a math interest?
Yeah, I studied at the Royal Institute of Technology, applied physics. I like physics a lot. I planned to do research in physics, but I ended up doing research in mathematics. I'm still very interested in physics. And also artificial general intelligence is also a topic of interest. So, when I studied, a lot of my friends, they studied both at the Royal Institute of Technology and Handelshögskolan, whatever you say in Swedish.
Yeah, School of Economics.
School of Economics, yeah. And I thought about maybe doing that as well, but instead of doing that, I started companies. So
what was the first company you started then?
The first company was a crappy one. We made market research. We made market research with I don't know the English word for that as well. Talsvar.
And phone, the phone. When
the phone. You could use
the buttons on the old phone,
Yeah.
and then if it's a 1, 2, 2, 5, press the 5 now.
Yeah, exactly. So that was quite new at that time. So we ended up with some projects, and then in 1998, me and some friends from Royal Institute, we started a company more known under its product name JRocket. So this was a virtual machine for Java, which solved a big problem at the time, because everyone wanted to use Java. Java was good for like small systems with a small footprint, but there was a problem using Java on the server side. So because the Java virtual machine accessible at that time, which was like Sun Microsystems hotspot, didn't work properly. So we made an adaptive, self-adaptive optimizing virtual machine. So sort of rule-based AI, we could call it today, if you like. And
Everything's AI.
Yeah. But at that time, everything was IT. So it was this IT boom. So we had to call our company an IT company. Anyway, so this was very successful, and we sold the company to BI Systems in Silicon Valley. And BI Systems was then acquired by Oracle. And this product is still running on 20 million servers worldwide, and it's a de facto standard for Linux. And moving to today, we reassembled part of this team. So me, Joachim, Peter, Marcus from the Rocket are in this new company. So I joke and said we're like the movie The Expendables, you know, with
that would be a cool
Stallone and Dolph and
I need to think the webpage.
Yeah.
But and I first time I saw we met at the one of the conferences.
HPC conference, RISE.
High Performance Computing Conference. Yeah. And immediately, you're at SICS. So I thought, this must be a homage to the original SICS.
Yeah, exactly. So that's so one part of the company is this Expendables. The other part of the company is there are at least three people from originating from SICS in the company. So SICS, Swedish Institute of Computer Science, doesn't exist anymore. It's a part of RISE. So the name is not used anymore. And we had this since we had this Niklas, who is in the board of directors. Niklas Rudemo is from RISE. He was like deputy head of RISE, something like that, deputy director. And then we have Don Gilblad, who is the head of AI, was the head of AI at SICS.
Is he part of the new company as well?
Yeah, he's part of the company. And then we have also Jussi Karlgren, who's very skilled in computer linguistics. So he has helping. Yeah, I'm sure you know him.
Daniel has been here.
Yeah.
Has Jussi been here yet? We've been both Jussi and Dan. You're late to the party.
I'm the new kid on the block. The Jussi and Daniel, they've been around for like 25 years. So
and I've been doing the AI profiling. So Superintelligence.
Yeah, so the name, we took the name as a working name for the company when we started it as a project, and then we got stuck with it. So we registered SICS.ai. Today it's very difficult to find an .ai domain, so we stick with this. It's a short, good name. So
And Superintelligence, it's the same as Ilya Sutskever's name, right? It's Superintelligence.
Safe Superintelligence is his company. He was after us. So
he was after, but I just love the homage to people working at SICS.
It's a very good institution. There are a lot of interesting companies. For example, Databricks originates from SICS.
You have the
company valuation of like at least $38 billion last time I checked.
You had the Godse, was it Godse?
Yeah, he's the founder of Databricks.
I know. And he was, what years was he at SICS?
I don't remember, but he worked together with Daniel for a while.
Wow, what a duck pond,
It's a small world.
It's a small world.
Duck pond,
And finally I met you guys. Really nice to meet you.
Now you're getting the connections.
But I worked a lot with SICS at that time as well. Then I was Spotify, but still, it was a lot of fun.
Yeah, and we had Lalle, of course. I mean, like, there's so many great people coming out of the SICS era. So many.
It's important. It was an important institution at that time.
But please tell us a bit about the origin of the new, not the old SICS, but the new Superintelligence Computing System. How did that get started?
Yeah, so I made an exit around 2015. I grew my hair, became jazz musician for some years. And then I had a discussion with some friends who are now in the company about, what could be like next generation AI. Today's AI is very boring. So, or like real intelligence somewhere on the roadmap or where. And then I spoke to Per-Erik Olsson, who's one of he's a co-founder of the company. He's also the co-founder of MySQL. Very brilliant guy, a genius with a capital letter.
And use MySQL in a nutshell for the people who don't know.
Yeah, MySQL is a standard open source database used by like 150,000 companies worldwide, and today is also like JRocket part of
many
of Oracle. Yeah.
And he was one of the founders of that open source project.
Yeah. So and Per-Erik, he's been working also with AI since the 80s, so he's really skilled. He's probably the most skilled AI engineer in Sweden. There's only, as far as I know, Daniel who can match him in AI skills. So anyway, we spoke about this next generation AI. And then Per-Erik said, because at the time he lived on a farm, I don't know why, but anyway, so he said, well, I'm coming to Stockholm next week, I'll tell you. And then we had dinner and discussed AI. And he showed me an American company. It's called Numenta. There's it's founded by Jeff Hawkins, who was one of the founders of Palm Pilot. And they had some interesting ideas. So Numenta, yeah. So if you want to have some sort of idea about where we started, you can have a look at Numenta's homepage. But so basically, what Jeff Hawkins did, he wanted to make a computer model of the brain. That was the end goal. Very ambitious one. But he had some interesting ideas about how the brain works, which are not like. I would say standard neuroscience theories. So this was an amazing, inspiring moment.
And this was in year like 2000?
2017, 2018, something like that.
Yeah.
And then we had discussions about AI, and then we brought in Donny Gillblad, who used to he was the director of AI, both at Chalmers University and also this Swedish Institute of Computer Science. Yeah. And then we spent like several hundreds of workshops crafting a AI model or AI architecture for artificial general intelligence. So basically, from first principles, what is intelligence?
Do you have a preferred definition?
Yeah, sure. It's an easy one. So, intelligence is a feature of nature. It's as a concept, it's not really well defined in science. But if you look at it as a feature of nature, and try to understand why it has appeared in nature and what it's used for. So, intelligence. What's the use of intelligence in nature? If I may ask you, what would you say?
Well, I can go and speak about this for half an hour, but
yeah,
I have
no
my
problem.
preferred definition. Yeah. I actually changed my mind about this. So the one I prefer today is coming from 2019 and the paper from Francis Jolet, and he basically defined intelligence as the skill acquisition efficiency. So the ability to actually acquire a new skill. It's not about having knowledge. It's really about the efficiency of acquiring a new skill. And not knowledge, but really skill, meaning the capacity to do something real, so to speak. So that's my preferred.
That's a very good definition.
Let me give an other angle on this, and then back to you, how you continue. I think that whole definition of intelligence is almost very, very hard, as you say. It becomes philosophical, but you can look at what are intelligent behavior. So this is closer to when you say what is the feature of intelligence. And if you look at that, that I think holds both in biology, but would also hold in enterprise, is ultimately, let's see how we put it, but it's about doing the most rational or relevant decisions and actions in mutually adaptive in a larger context. So it's about cybernetics, feedback loops. It's about how that in order to have intelligent behavior, you need to have the right context to act intelligently, to behave intelligently. But ultimately, it's then something that is close to based on your objective, based on your context, what is the most logical next step or decision, and that then sort of manifests intelligent behavior. It's a long one because I couldn't remember my researcher's brilliant summary. I was trying to frame it, but you understand the essence of it.
Yeah. So I would say in that context, our definition of intelligence, or the way to understand what intelligence is, it's much more naive, so and much more basic in a way. So in a very down to earth way, the purpose of intelligence in nature is to survive.
Yeah.
And what's the most basic skills in order to survive? Eat and avoid to be eaten yourself. In order to find food, in order to run when there's a lion around, there's one, I would say, capability behind: navigation.
So, like a shark, a shark is really good in surviving. Does that mean that shark is intelligent?
Yeah. So intelligence is closely related to navigation. And if you think about what navigation actually is, navigation is about planning, reasoning, simulation, prediction, and independent of what kind of definition you have for intelligence, those are like basic intelligence skills.
First principles,
First principles intelligence skills.
You're trying to sort out what is first principles of intelligent behavior, or intelligent characteristics.
Yeah. So our conclusion is, if you have solved properly the problem of navigation, you have basic intelligence.
So is a dolphin more intelligent than a shark?
Probably. It's how do you measure intelligence? So you can use an IQ scale. Doesn't work for dogs. You can use some sort of. You can have animals looking at themselves in the mirror and see if they recognize that they see themselves in the mirror or not. So this is one example. So how do you level? How you measure different type of intelligence is actually also content based. So. There's one scientist, I don't remember his name, but he argues that probably the liver in the body possesses some level of intelligence, and we are not intelligent enough to speak to the liver and understand what the word is like for the liver, because there's a complexity in the environment. There's a problem to solve, serving the body with the poison. Cleaning the blood.
So in your view, intelligence has nothing to do with adaptability or anything. It's just the capability of doing something. Or?
It has. There are, I would say, a relation to complexity.
Okay.
So if you can master a more complex environment, if you can master more complex tasks and solve more complex problems, then you're more intelligent than not. So, for example, a rat is less intelligent than a cat is less intelligent than a human, and a human is less intelligent than our computers. So.
But I'm trying to, if we just compare it to the skill acquisition efficiency definition, if we take playing chess as a capability, for example, you could be a person that has trained throughout his whole life to play chess, and it took like 20 years to get semi-good, perhaps. I'm not speaking about Magnus Carlsen because he's extraordinary, but just whatever person. And then another person learns to play chess in a week. They both potentially are on the same level, but one has had to learn for 20 years and another one learned it in a week. Would you still consider them to have the same level of intelligence in that case?
Chess is a bad example. Chess is interesting because this is a quote from Yann LeCun. It shows more like that we humans are not so good at chess. So
still, it can be any capability. Just an example. But doesn't the efficiency of acquiring it play any role, or is basically intelligence the same as knowledge, or the ability to perform a skill?
There's definitely a relation to the speed of acquisition of the skill, I would say. Yeah.
The speed of acquiring a skill. Okay.
Yeah, okay. But also there's another dimension. So it's easy to work one dimensional. But if you add like the volume of data you need to acquire the skill.
Yeah.
So you have like time, but you have volume. So and if this person who's learned chess in a week has consumed the same volume of data as this person who's done it for 20 years. So it's basically the same.
But something that requires less data is probably more intelligent if they can then reach the same level of quality.
I would say that.
So it's something about skill acquisition efficiency still, right?
Yeah, I would say, yeah. Okay. But that turns, and this boils down to, okay, so if we in this context agree that intelligence is related to navigation, so what's navigation? How is navigation related to more general intelligence and higher cognition? So moving something from A to B, that's a navigational problem to solve, and moving yourself is the same type of problem. And if you consider all the type of objects that exist in the world, all type of materials and so forth, there's a lot of information, and there's a need to generalize in order to master the world. And if you can master the most simple robot task of pick and place, actually when you have that, you already have some capability to do basic assembly, putting two things together. That's pick and place, but maybe two arms and a more advanced destination. So you can go from pick and place and a combination of pick and place actions. Then you have a more complex behavior. And how is this related to higher cognitive functions? Well, our view is that solving problems is still navigation and pick and place in an abstract realm. So when you're looking for example, when I'm looking for this Fermat proof, I explore different paths in the head. I'm moving mathematical symbols around when I'm taking a shower, and all of a sudden I can see a pattern. I can see some sort of destination. So if you have navigation in a sort of naive real world, you have the basis for artificial general intelligence, and this is what we have built.
So this is so it's somewhere to crack the code, the fundamental lowest level first principle architecture for navigation.
Exactly.
And then as you do that, it's a matter of scaling that into more and more complex or abstract context.
Correct. So you need to master pick and place first, then you can do industrial assembly, maybe some construction sort of, and then you can make a PowerPoint later, but you cannot start. It's like a baby. You can't put a baby in a car and expect it to learn how to drive. But a 17-year-old can learn how to drive in a few hours. So, and this goes back to the other analogy or the principle of navigation. So, what do you need in order to navigate?
A world model.
Yes, a map of the world. You need a sort of map, so you know where you are, where the objects are, the relation between the objects. It must have some sort of model of basic physics. And this type of and this model is structured. The key word here is structure. Today's AI model don't have this type of structure.
Hold you for a second, because we're getting into a really interesting topic. But I just want to finish the previous topic, which was, what was the origin of the company, the Superintelligence Computing Systems. So if we just, try to figure that out, and then we get back to this point, what are you trying to do there? And
sure. So the realization was, if you can describe superintelligence, if you have like a blueprint for superintelligence, you can actually build it. That was the realization. So let's do it.
And the logic here is that how can anyone has a blueprint for superintelligence? When you start top down, or if you start on the right angle, it becomes impossible. But what you're trying to do is trying to sort out the principal pattern that you can now scale, or that you can now take into more complex. So to crack the inner pattern.
Yeah, it's a very good summary. So in our view, today's AI is a top-down approach. A lot of data, so forth, brute force, but we're doing it bottom-up instead.
Trying to crack the inner pattern.
Yeah, and in order to build a structured model, you need a mathematics that have which is good at capturing structure and which is structure preserving. And when you have that, when you have this structure, you solve many problems with today's AI in one swoop. For example, with structure, you get stability. You get much more robustness.
This is the value prop, and then we pick it apart.
and also with structure, you have better transparency, but better understanding what the model is about. So it's not just a black box anymore. And also, the structure makes the information available for many-step reasoning in a stable way.
There's so many tangents here, because as soon as you now say, like, we want to do deep learning, we don't want to do the mathematical fundamental principle that can scale and learn by itself, but you're also, with the world model view, you're entering into this is structure somewhere also. And now you're getting into this whole neurosymbolic or whatever we want to talk about, how these worlds merge. Even these conversations happen anywhere else as well. So this is, but because you have some part here in your thinking, which is structure, and one that is learning.
Yeah, exactly. Yeah, very.
Okay, so you came together a number of really famous expandable. No, that's not expandable.
Expandable stuff. We're gonna say
Expandables. That's another movie.
Hey, man.
But okay, so you formed the company in at what year was it?
2022. In December, we finally founded the company. Then we had the sufficient, I would say, work done on the AI model to start using it in a real life setting.
So workshop, or get-togethers and whiteboards. Or
whiteboards.
Since between 17 and 22, really.
COVID was like that was special. Difficult to use whiteboards, but we managed somehow. Yeah.
So the goal of the company, I guess it's evident from the name, but still, what are you trying to do with the company?
Yeah, the end game is artificial superintelligence. Yeah, it's cool. It's pretty cool.
But also
it's
now, when you start with the pattern view, you can now start applying it and solving narrow tasks as you grow to more and more complex tasks, and you can have usefulness. I assume is your idea, without having reached superintelligence, whatever definition that is.
That's a somewhat valid point, but actually, what we're doing, the development of the AI follows the development of a child. So the first thing we need to do, like a child, when we're born, we have like 700 megabytes of information on our DNA. That's nothing. A grown human has like 20 petabytes of information stored in the brain. All this information needs to be learned. And basic things about the world needs to be learned by a baby. Between 6 and 9 months, babies spend a lot of time learning about gravity, how that works. A baby doesn't first understand called the object permanence, that when daddy leaves, he's gone forever in the baby's world. So these things, basic things, have to be learned. So we need also to start at this baby level. So we have a baby AI right now doing pick and place, like a baby playing with his toys. And this it appears to be a narrow task, this pick and place. And when I spoke to Ove Leichenstring, he showed me an article from ASEA from 1984, where they had a rule-based system for doing pick and place automatically with a robot. So this is like very old news. And pick and place has been solved in the specific case since that time. But the general case, to be able to handle all type of objects in all type of environments, all type of materials, that's an unsolved problem. And this problem needs to be addressed and solved first. When you have that, you have the foundation to grow further. So this general case is not a narrow task. It's a super task that requires artificial general intelligence to be solved. And also the other way around. If you have solved it, you have artificial general intelligence, or the basis of it.
And is this the reason why you quite fast moved into robotics as your physical intelligence, so to speak, physical movement as a key focus of your AI?
Yeah, it's great fun.
Cool.
But the thing is, since we have an AI that has a different type of learning, and which is interaction with the world and the environment. If you have a physical interaction with the world, it's much easier to understand if you're on the right track with your development.
Yeah, it's something that is actually quite measurable or observable.
Yeah, and there's an abundance of training data. Just put some sensors up, cameras, tactics, or whatever. You have an abundance of data to use for your training.
And I know you don't want to go too much into the details how it works, but still, if you were to, in an abstract way, still describe what is different from your design architecture of how your AI works compared to the AI of today.
And AI of today, would we use the LLM baseline or that
AI
approach?
in general, deep learning or traditional machine learning, or even rule-based, if you want to.
Yeah, that would require entering into the mathematical structure behind. So I can tell you what it's not. Okay. If I describe today's AI, which is a brute force approach, you have trillions of parameters. It's a huge black box. With a large parameter space, you can parrot any type of input data in your mathematical model. But the parameters, they are really, this example with the synthesizer. So if I say something, say hello, I get a sound file. I can use 10,000 voices, adjusting the amplitude of the sine waves, the phase and the frequency, and I can make the system imitate and say hello. But there's no understanding behind. So this is the way that today's AI works. So in order to make the system more intelligent, in order to build a foundation for this word model, you need to find a mathematics that is richer in structure. I can give another analogy. This is from physics. There was a famous physicist. He became famous after an equation that he discovered, the Dirac equation. So Dirac, he struggled with merging physics, special relativity, and quantum physics. And he had this equation, and he tried different variants. And then by some peculiar reason, nobody knows why, it's a mystery, but he replaced numbers, pure or variables, with a more sophisticated mathematical device called matrices. And when he did this, all of a sudden, the equation worked. And with this more complex mathematical structure, he could infer theoretically from the equation that antimatter exists. So he discovered antimatter through mathematics, through the structure, through the more richer structure mathematical representation. So
the analogy here is that we need to replace with a more sophisticated math or more sophisticated architectural structure. It's still fundamental principles, but simply as he did go to matrices approaches, something then happens.
Yeah, exactly.
And this is now we're touching the core IP. Like you're thinking about different mathematical structures.
Exactly.
At the right
and again, same thing with Einstein. So when he wanted to add gravity to his special relativity, he needed another type of mathematics, and he used this Riemann mathematics with curved space, which was already existing pre-Einstein times. And also a lot of the results from physics about the length contraction and time dilation, this was also results known before Einstein. It's called Lorentz Fitzgerald contraction. So Einstein, he managed to put things together with, again, some fundamental and very simple principles, actually. The speed of light is constant, and the laws of nature, they behave in the same way in different of if you move different reference frames.
Would it be fair to say that when the team came together in 17 to 22, you had this, has this emerged as a strategy, what you're trying to do, replace some with more sophisticated math? Or was that the founding ideas that maybe one way to get faster or closer to AGI is to simply do this, finding the right more sophisticated math? Was that emergent, or did you think like that from the beginning?
Well, the development. So when you think about things and when you're solving a problem, you're going in that direction, and then you go another direction. So you need to start to do this homework about what intelligence is, what kind of feature you would like to capture, and how.
And that's a long discussion in itself.
And that's a long discussion in itself.
Yeah.
So this is an important feature. This maybe not. This might be. Could we borrow this from neuroscience? Is that a good principle? Yeah, it was a good principle for a while. Then it was thrown out. So it's an iterative development. So we started in this end, and we ended up over there, and then we're back, and then we reuse some ideas from 5 years ago, and so forth. So
iterative is the real answer.
But if you were to describe a bit how it works today, and the thing you actually have put in production, if I understand correctly, how would you describe it without giving away too much secrets, so to speak?
Yeah, the most interesting feature is probably that it learns through feedback. So it's not the traditional batch learning AI. So it's more human-like in that sense, and this turned out to be much more efficient. So the training cost of the AI we have on site today is virtually zero.
So compared to how it normally works today, you have these kind of batch or offline training where you have a huge data set and you train over and over again and then update parameter, and then you start to use it in inference mode. So you have this completely separate training and inference mode. But I guess if I understand correctly, you have more of an online mode, meaning you actually do both training and inference at the same time. Is that correct?
That's a simplification, but that I would say online learning is the end game. So the thing we have in production right now is continual learning.
Can you help me, who is not as deep as you guys? What's the difference between continual and online?
Continuous learning, online learning, then you learn all the time. Yeah. Continual learning, you have chopped up it somehow. And you can for this use case pick a place, you don't need to feed back the model like every minute, something like that. So you have you can keep just long time intervals if you like, but you can make them shorter if needed. So I would say, depending of the complexity of the task, you need to
go faster, shorter and shorter.
Yeah.
So it's not like online in like every kind of data point, but it's some kind of small batches that updates the model.
It's not really like that either. So, but I can go more into detail. Sorry about that.
Oh, you can't.
It's a different setup altogether in that aspect. So.
Is that the challenge sometimes when you want to describe your thinking and philosophy here? Because we are now going down so deep for the last couple of years in some certain patterns, and we talk about, it's pre-written. What's training? What's inference? So it's all, we're already down in one rabbit hole, so to speak. And now you're saying something, those words, I could use them, but they're not really my words. I need now the semantics to capture this.
Exactly. And we have this IP protection because we're not a research project. We are funded by VCs. And about the difficulties, a VC asked me in this type of pitch session, what's the most difficult question you got from a VC? It's like, how does it work? So yeah, it's a big problem, and it's.
Okay, perhaps we can get back later too, if we can try to poke you more later. But okay, I get you. We can't really go into too much detail there, but perhaps you can speak about the application a bit, because you do have used it for real, so to speak. So if you could, what is your current system used for today?
Yeah. So if you look at industry automation, there are like 3 core values. First one is robustness. This is very important. A typical industrial robot can run like 100,000 hours mean time between failure if it's oil changed and so forth, properly served. It's like 20,000 hours to the first oil change. So robustness is key. And this is a problem with today's AI, with hallucinations and so forth. So due to this problem with hallucinations, AI cannot be widely used in industry. Second is scalability. Same robot, same program, anywhere in the world would do the same job perfectly. But with AI, well, the AI deployed today in industry in pick and place, it needs a lot of data to run. And the more complex environment you have, the more progress you have.
Specific for the environment.
Yeah. So there's this training makes today's AI not enough scalable. So not cost efficient enough. As you said before, that if you have a big enough model and enough data, then you can keep the outcome decent, but you don't really know when it will fail. So the mean today you have in order to mitigate this is you don't have end-to-end AI. You have a mix, a hybrid between AI and program. So the program is needed for safety guardrails. It has like human heuristics, handle special cases, so forth, which degrades the scalability. So this is the problem today. To summarize, traditional robots, robust, scalable, not so flexible. AI, flexible, but not robust and not scalable. So what we have with our solution, high level in industry, we managed to have flexibility without cannibalizing on robustness and scalability. So this is basically the problem we're solving. We're adding robustness, opening up for wide-scale deployment of AI in automation.
But you also do have...
and also if you look at industry today, if you look at warehouse logistics, you could potentially automate pick and place. 95% of all warehouses have no sophisticated automation. Amazon's warehouse in Sweden, 0 automation, 400 people picking goods. Leaders' warehouse in Halmstad, no automation. because it's a complex environment with high variability, unpredictability, and unstructured. And if you look at industry and assembly, well, you think about industry, manufacturing industry, lots of robots. Yes, but between 70 and 90% of all assembly work is still manual. Because the environment is too challenging for today's robots.
So flexibility is not the strong feat. So, when Amazon is doing something super cool, it's because they're highly standardized, a very specific warehouse, and then it works.
Yeah.
But and the same with in car manufacturing, you can highly standardize certain tasks, and then it works. But then all the complexity around there, or that still takes too much time to retrain or find a new model, or each step needs its own model, etc., etc. So that's the flexibility, that having something that you can redirect to other patterns, to learn something new.
Yeah. But I guess in short, it's basically that I think people overestimate what AI can do today. Right? If you put it in real world situation, it can't really do that much. Right?
Yeah. So solid real world AI.
Yeah.
That's the key to intelligence, to real intelligence.
And this is, many are going down this path that, are we really solving real world intelligence when we are going down this linguistic way?
No.
This is a fast answer, right? and then we've been joking about why is, who is on top of this race? And we always said, don't count Elon out because he's working on all the angles with his Tesla car, with his robotics and etc. So that, but it's something
he's using the term real world AI a lot. So,
yeah.
But still, we love to just understand a bit, what is the use case? I don't think people really have heard yet, what are you using it for?
Yeah. So back to warehouse. So in warehouse logistics, the business of warehouse logistics is moving things from A to B. It could be products, it could be cars, it could be whatever. And it's very important with the precision. If you move the things to the wrong place, that costs quite a lot. So this the core functionality you must have is robustness, and you have to master also a bit more complex environment than you have in manufacturing industry, where you're moving the same pieces all the time.
But to put words in your mouth, sorry for that. But in short, you have a robot that you control with your AI that can move parts on the production line in different places.
Yeah, thanks. Exactly. So we do pick and place automation.
Yes.
So our AI is controlling a robot. You can say that it's an AI robot brain that we're building.
Can you explain you had a very nice example case before we started the pod, which is a quite interesting one with a lot of different SKUs pieces and with a lot of variety every year.
Yeah.
Can you explain? Because I think that sets the tone.
Yeah, sure.
It exemplifies for me really well.
Yeah. So again, these core values: robustness, flexibility, scalability. Flexibility, a way of having flexibility. The need for flexibility is if you have high variability. So in this case, we have 20,000 different type of products, and you have 2,000 new products entering every month. So you have this problem with variability, and we can handle that with our AI. And for a very, I would say, reasonable effort. And then we have the robustness, the pick and place accuracy, and we are picking with nearly 100% accuracy of these products. And how are they presented to the AI robot? Well, they enter on the conveyor, sort of, not really, but they enter in a bin, unordered, in a pile. So it's what you call 3D picking. If you have the items neatly on the table, that's 2D picking. But this is really 3D picking.
So, okay, so with picking and placing the different parts in a proper place, and it is adaptable, I guess, because it can handle new parts. Yeah. So you said something about 2,000 new objects coming in every month or something, and replacing others. How does it know what to do properly then? Is some human showing it how to do it, or is it adapting or learning in another way?
Yeah, so we're engineers. So we're taking all the shortcuts we have available to bootstrap the system. So before it's put in production, it's bootstrapped in different ways. If we have ready-made metadata, we can use that. And then as that starting point, it improves from that on. And then we come to the third dimension, which is scalability. So this AI model is crafted in such a way that it's one AI model that control all the robots. How is this possible? Well, all the robots that live in the same world. So if you have a good generalization in your word model, it can be used by different type of robots.
But what happens if a new object comes in here and they've never seen that before? How does it know what to do with it then?
How would you do?
I asked a friend or a colleague to show me what to do.
That's one way of doing it. Huh?
And how does your system do it?
Or the other ways to learn?
I don't know. So you tell me.
Now, if you experience this can, and you can you give me the can, and you don't know how to lift it, what do? You try out, yeah.
You try out to read the label, you see what it says. You take it up and you try to figure out what's information can I gather from this.
Yeah.
And then
you have your memory, you have your word model. This resembles something that you have experienced before, maybe not. Huh? And if it's completely new, then you need to be like curious.
So no human feedback at all?
No. Okay. No. I would not say no. We can use human feedback if we like, and to bootstrap the system. So, and also, I haven't spoken about language, but again, if you have structure, you have the basis for language. So you can have a language which is semantically grounded in the real world, and you can, if you have that, you can actually teach the system using language, which is bottom-up grounded and not this type of large language model type of language. So this can also be used to teach the system. And the system can also communicate back with and ask questions. And those are real questions. Like, so I spoke with Jussi about that. So what's the easiest type of language that you can have in this type of system? Is it like yes or no? And Jussi said like, no. Why is that? Well, no is a very complicated linguistic term, whatever. How is that? Well, no is heavily context dependent. You can't understand what no is unless you know a lot of things about your environment. So this is a very complicated thing to use. Okay, so what can we use instead? Where do we start? Well, probably the most basic linguistic start for the system is you can communicate normal conditions, and then when you have something that deviates from the normal condition, the system can alarm you like a baby. So
can your system understand text and speech today?
If we would like it to do so, I would say we don't have the linguistic capabilities implemented in the system today.
Yeah.
But there's nothing that, in principle, prevents it from having that type of capability. So,
okay.
But I think this is super interesting, and I think we could do the whole pod here. But we also have a bigger theme. Do we want to? I could stay here, but also I'm curious to stay on the bigger topics of AGI. Because even before the camera was on, we can come into a real discussion and debate on what is AGI or and down into the theme. So what do you think, Anders?
Yeah, I think it's gone 1 hour. The question is if we should do a new section or not, or should we?
Since this is the first pod for the year, and there's been some stuff going on.
Yeah,
I think we should have a little small news section. We usually break in the middle and talk about Did you hear about this? Or have you tried that?
Yeah, but let's do it.
Let's do it.
It's time for AI News, brought to you by AIAW Podcast.
Cool. Yeah, as I said, Henrik, we usually take a small break. We usually fail in making it small, but we try to make it small. And
that's just fun to
to speak about some favorite news that happened in recent weeks, or it gets longer in this case, potentially. Yeah. Anyone that wants to start to have some favorite news? Have you something Karim, that you heard about recently? Some news article?
Something you tried, a new model or whatever?
I like these humanoid robots doing karate kicks. I don't know if that's the news, but
the
it's
Unitree thing, or which one?
Yeah, that one, with a watermelon.
Yeah, that was really cool.
I mean, like one topic that sort of no one has missed is the whole what's it called?
Claudebot, but it's changed name to Multibot now. But
yeah. The whole thing, and that where people start setting up their Mac Minis at home, and with no
I don't have a Mac
and no authority, letting it loose, and it's amazingly powerful. But
it is.
Should we say something about that? What is your take on that?
No, it's really cool. And just to give some background about this, it's based, we had Claude Code, which is like a command line tool that is really powerful, and you can do a lot of coding with it, and a lot of other stuff besides coding as well. And you control it through the terminal. And then recently, Anthropic also released Claude Cowork, which is a bigger framework where you can actually operate.
Yeah, we should have mentioned that first.
Yeah, so you can basically operate on your machine, and it can have access to files, and it can do much more than you otherwise could. So it really...
And the value prop was to get it out of the hands of the pure coder, and make normal people find the value of it.
Yes, so it's more of a agentic assistant, or what we should call it, but it really enables it to take action to an extent that wasn't possible before, and in very much easier way of using it as well. But then there came this kind of open source framework.
Open source, that's the point, right?
From a single person that created what they call the Claude bot.
Claude bot open source.
But it wasn't spelled like Claude does. It's basically spelled like the crawfish kind of thing, with a claw. But then Anthropic sued them and said, you can't use this, even though it's spelled differently. It sounds like Claude, so you can't do it. But it's basically based on the idea of Claude Cowork. It's just adding a lot of integrations to it and a lot of functionality, and makes it much more general than what Cowork was. So it's super easy to install. It can run on Linux, Windows, Mac, or whatever. And then you can connect, all the different type of accounts to it. You just give your password away to all the WhatsApp,
give your life away, and it will
Telegram, Signal accounts, or whatever. And it can read it. It can write there, and it can start to interact with people in a way that is very, very nice, but also a bit scary.
Yeah, but this is so many ongoing. This is so many tangent stories here. So, like, one story is about people put it straight on the port with no security and so it's completely open. It was a side story that all of a sudden now all Mac Minis got sold out because people went. People realize, the architecture in a Mac Mini is quite useful for this, So there was this tangent story, GPU and NVIDIA is dead. Now Apple will take over with the world with Mac Minis. So there was many side stories that made this whole very interesting couple of weeks.
But it's also a big shift in how traditional chatbot works compared to this one, because the traditional chatbot is very reactive, meaning it doesn't do anything until you tell it to do something. This one is much more proactive, so it can basically go and check, every 5 minutes or whatever you want for something that happened, and then it contacts you. And it also has this kind of, I'm not sure what they call it, but self-learning kind of abilities. So it tries to do things, and when it finds out that suddenly the way I usually answer an email or whatever doesn't work anymore, then it actually self-corrects. And it does so without the user telling it to do so. So it's trying constantly to improve its skills. So it has a set of skills, similar to Anthropic skills. And it's really cool. So becoming these kind of more proactive agent or assistant or butler or whatever you like to call it, that take actions without you telling it to do, and then having access to all your accounts and whatnot, is a step change, I would say.
Yeah, but and I'm interested in the bigger picture here. I mean, so one of the key bigger pictures is that I think, you are discarding the whole LLM story altogether. So.
No, it's an amazing engineering feat and very, very useful. And Per-Erik is trying to convince me to use this Claude whatever, and I've been really skeptic. But when I tried Claude with this mathematical proof, now it's on my to-do list to install this.
But the whole Mac Mini story to me really shows that if people think AI will only grow up around one axis, the fundamental logic of large LLMs and more compute on that, I think that in all its patterns, it's showing that the way we reach AGI is, more access that will need to be better. And here we have the example of, cloud, the Mac Mini will not take over, but it clearly separates what you want to do locally versus what you want to do centrally.
Yeah.
So, and
that's a shift.
For us, this is obvious, right? But for a lot of people, I don't think they don't see that.
And I have to say, you don't have to use a Mac Mini for this. I hate Apple, by the way, so I could say that. You can use, NVIDIA has awesome DDX Spark machines and whatnot that is perfect for this. So you don't have to use a Mac Mini. Anyway, but I think, one interesting part is really the adaptation it is having. So, we have, of course, the LLM underneath, and it is hard code, or it is fixed. It's offline trained, right? So it doesn't update the actual model it uses. It actually uses the APIs. You just go to Gemini or Claude or OpenAI, whatever. But it does adapt other things. So it does basically have a set of markdown files, simply text files that it saves on the file system. And then it updates those all the time. So it has a long-term memory that it does. It has skills, and it has, I think it called it a soul, personality. So it tries to adapt to the personality that you like. And it constantly updates that by itself. So by adding this kind of scaffolding or extra parts of the system to it, it does start to have a memory that the normal kind of LLM does not have. It starts to actually have a more of a behavior adaptation that a normal LLM does not have. It does actually come a bit closer to continuous learning, meaning it doesn't really change the parameters of the model, but it changes the skill files and the other parts autonomously.
Yeah, and this to me, I want to try it with you. It also pushes to me a much clearer view that, if you want to do AI properly, you need to have a systemic thinking about it, and you need to build with today's technology to make that work and to minimize hallucinations or make it. You need to build AI compound systems. So you're sorting out, you might have a core LLM somewhere, but to do it with today's technology, you need the other parts. And what you see, what this open source project is several moving parts that together makes us closer to continual learning, makes us closer to this and this and this.
And it makes us closer to the JEPA architecture. And I think we should go there, because I know you also, as me, has a big interest in the Yann LeCun kind of JEPA architecture, which does have multiple modalities.
And we have talked about this on this pod for several years now, that it's not about the problem that with the LLM, it's the problem that people think that's the only thing. And actually quite sophisticated big projects or enterprises they don't understand the problem with learning and navigation, and that okay, you can solve that with
if you in some way, magical way, could make the LLMs have like a dynamic long-term memory, the problem is solved. This may be some people are hoping. In the brain you have like the neocortex, where you have this long-term memory, and then they have a sort of scratch board short-term memory in the hippocampus. So with this new type of Claude thing, whatever, you have some sort of hippocampus layer which works, but it's not really.
There are more things than memory that's required to achieve AGI. But let's go there.
Do we have some more? This was the one main news. I could not help also. Have you followed the whole new hype word of context graphs? That also, like if something we didn't talk about before Christmas that really exploded in January, context graph this and context graph that. Or maybe that's not a news maybe, but it's someone wrote a paper and someone tried to push that whole logic. And nothing that you really.
knowledge graph is like old stuff.
Not knowledge graph, context graph.
Yeah.
Okay, let's not call it.
Perhaps a small story could still be that they're starting to put ads in ChatGPT, though. Yeah. But I guess they have to do that.
That's the monetization model problem.
Yeah.
Anything else that was sort of there was some new. We can stop here and we can take it next week. I think this one was the fun one to talk about.
Yeah. Okay. So getting back to that, and I'm not sure how to, but should we go perhaps to the JEPA? And
that's a good segue.
Just continue there. What's your view of how would you describe what JEPA is?
No, regarding Yann LeCun, we share some high-level ideas with Yann LeCun, but not the JEPA, I would say.
Okay.
And there's something that works with, but there's some fundamental flaws in it which prevent it for really work. And I can't really talk about it. I would love to do it, but it's
talk about the problems with JEPA then.
I can just give a hint. Some.
What is good with JEPA and what's problematic with JEPA?
It's an off ramp if you want to build AGI, and I can't really tell you why.
Yes, you can. Come on. Okay,
so much fun.
But okay, how would you describe JEPA then? If you start there,
it's okay, high level. I can maybe explain it this way. Yann LeCun is not into robotics, so if you're challenged with the real world and the interaction with the real world, you have another set of problems to solve than is on the table for Yann LeCun. So that's one way of
But if I give a quick context then, or my view of JEPA perhaps, and then we can continue from that point. And he's been famous for saying that he doesn't like the autoregressive nature of LLMs, meaning that the error compounds as predict next token after the other, and it can't really backtrack once you predicted one of the tokens, so it just will have an exponential increase in error as you autoregressively continue to predict token for token. So he wants to find an alternative to this, and then he has this kind of joint embedding predictive architecture where he wants to do the prediction in some kind of latent space or energy space, as he call it. So instead of having to predict one token all the time and going, through the whole model with a full forward pass for every single token, and then, taking the previous token that you generated, which is syntactic, what token it should be, going back into some kind of middle layer out of these hundreds of layers, semantic understanding of what the token mean, and then back to the syntactic representation in token space. It works semi-good for text because text is rather high-level abstraction, but it's impossible to do for pixels, for example, for videos and images. So even today's image generators do not do like this. So they're not autoregressive in this way. So even today's image generators work in a non-autoregressive way, I would say, similar to the path of Yann LeCun's predictions, meaning it has an autoencoder around it. It takes the pixels and find a latent representation. Then it do the diffusion transformer part of it. So it actually, instead of doing the autoregressive, do a diffusion from a very noisy version to the clear picture, as you see when you generate image today. And so it's already moved, I would say, in his direction. He doesn't say do not use transformers. He was basically the one that came up with the supervision techniques, so which autoregressive models use. I mean, he's very much in favor of transformers or using that type of techniques. It's just the autoregressive nature and being able to do prediction in kind of a sensor space or text space or pixel space that he objects to. But instead doing it in some kind of latent space, and then having these kind of world models and memory and different components that he has a beautiful picture of. And when they have that compound together and can do prediction, multiple step prediction, which I heard you speak about as well, in this kind of semantic space, just as we do as human when we reason and do not speak until we have thought. Some people do that anyway. But anyway, that's basically
a lot of system one going on in speaking sometimes.
Yes, yeah, but I think that's a good, then that's kind of hierarchical JEPA where you can do reasoning in different levels of abstraction, etc. But I would say, would that be a fair kind of description of what JEPA is? Would you say?
That's probably a good description.
Okay. But you also spoke a bit about, and I really, it's hard when you don't, want to divulge.
But let me try it like
details.
this. There's some, if we don't go now in the techniques, in the detailed techniques, but talk on principle level. So world model is something that you believe in.
Yeah, that's central.
And that's central, and that I think is central also for Yann LeCun's reasoning.
Yeah. We share that idea 100%.
That's fundamental idea as a principle. I think you're sharing the fundamental idea on online learning. That we need to go there.
Yeah, exactly.
And so basically, it's not enough until you have those components. And are those components the same as the core underlying LLM or whatever, or is it is this an architecture? So I can see how you share principal ideas.
Yeah.
Then how to tackle them might be where the magic source is.
Yeah, that's different.
Yeah, that's different. So let's argue on that one. What on principle level do you share ideas with Yann LeCun on these topics? The one we said now, and are there some fundamental principle you don't share with him?
You summoned it in good way. So a word model, structured word model, paired with online learning. That's the
essence.
That's the core
of
principles.
navigation.
Navigation is part of a word model. A word model is a necessary condition for navigation. So navigation is like operations on the word model or based on the word model. Paired also with, of course, sensory input. So you have the memory, the word model, and you have sensory input, and this a learning principle, which is say based on interaction and feedback. So.
But you still have some kind of backward propagation kind of learning, right?
I'm not going into details. Sorry, I'm really sorry about that.
Okay, now I respect that.
But let me. That is technically stupid, so I can't ask the tricky question. So, when we say online learning, have we solved the short-term memory versus long-term memory, or is this something completely different?
That's part of it. You need a long-term memory, and then you need a short-term memory, and they work differently, and they work together, and there's a stabilization in the learning with these two type of memories.
So online learning is key to get the stabilization right.
Yeah, the online learning is necessary to learn. Period. Yeah, it's necessary for
not necessarily to learn in the batch old way, but for real world usefulness.
Yeah. The different time scales and different applications and so forth. So everything I say is like simplification, first approximation and so forth. So.
Okay, but moving perhaps a bit to AGI kind of questions, and thinking you have made some statements about you think can come rather soon or very soon even.
Yeah.
But perhaps starting, what's your preferred way of describing what AGI is?
Yeah, so if we said today's, again, simplifications, but today's AI is good at facts, not so good at reasoning. Good at pattern matching, statistical parroting things, but there's no true reasoning behind.
Yes.
You can say that this somehow it's system 1, but not system 2.
Yes.
So AGI is system 2. AGI is the ability to do many-step complex reasoning or planning. Planning and reasoning is basically the same thing in a stable, robust way. So if you have that mechanism, you have the foundations of AGI. The rest is training the AGI to perform different type of tasks. So it's the ability to be able to learn any type of task. And like a child, you can't start with a complex task. You need to start with a more mundane task.
Basic task.
Yeah.
And then you can learning. So you start with something simple.
Exactly.
Yeah.
So you have curriculum learning, and you move towards more and more complex environments, tasks, and so forth. So an important component besides the architecture is something Donny Gilblad called machine didactics. You have to put the AI to school and have a well-crafted
curriculum.
Yes.
Okay, so
the problem with answering the question, will we have AGI in 24 months, 16 months? It's a gradual development, but it's based on one specific architecture that enables this gradual development.
Yeah, and because then we can come up to how do we define the cutoff point when we reach AGI, and we can use, if we use Sam Altman's, I think this is one of, it's a simple one to understand when you literally the computer can do what an average person can do, which means you're new at the job and you need to learn the job, but then you can do it. And then we can talk about doing that in the digital space versus doing that in the physical space. And then we can talk about AGI doing this at scale. And then we can talk about AGI regulated, from the lab and into everyday lives, right?
If you look at intelligence, we had the discussion, how do you measure intelligence? Is a dolphin more intelligent than a shark? That's a very interesting question. And I said it has probably something to do with complexity. And you have a rat is more intelligent than a bacteria, a cat more intelligent than a rat, probably, a human, hopefully, more intelligent than a cat. And then what levels are there beyond? Well, superhuman level 1, and then you have superhuman level 2, and then you have a skyscraper of intelligence levels. There's no limit to how intelligent the system, whatever, can be. And if our hypothesis is that once you have this AI architecture properly formed, and you teach it, so the first year is the most challenging, the corresponding knowledge. The second year is probably easier to, if you have properly if you can manage the environment and understand physics and objects and so forth. It's easier to add more complex behavior. It's just high complexity, more of the same. So our hypothesis is that the adolescence years, the 3, 4, 5 years, knowledge of a child, those are the most challenging. When you have that in place, the development of the AI or the capability of the AI will accelerate. So you will fast reach adult level, and then even faster superhuman level. So this is our hypothesis.
But there's a debate here when you want to put a number on something in terms of year. When will it happen and all that? But what I'm sensing now, I want to try it if I actually follow you right. So it could be like this, because this is of course a gradual thing.
Yeah.
And you say a gradual thing that is potentially exponential even.
Yeah. Bottom up and gradual exponential.
Yeah. So it means then that we will not understand. If from a surface observation level, as you said, right, you are solving a task that has been solved since the 80s, but in a completely different way,
yes,
which is narrow and limited, and now in an adolescent way, on its way to superintelligence. So maybe then a way to manage a debate on it cannot happen in 1 year is like, when we look back in 10 years, 20 years, when did we get on the path of superintelligence? The way I understand your definition is basically, well, if the architecture is there, that's the year when that's the birth of superintelligence. When will we recognize it as general intelligence? When will we recognize it as when we see it out in the world and we see it performing in the real world, which is maybe then. With regulation and everything, that could be 5 years, 10 years in practical AGI, so to speak. But what you are referring to is your ground zero for when did that AGI, when was that born? And you are saying then that... But
you're putting a lot of words in
I'm doing it.
No, it's great. It's great.
No, but I'm reflecting. This is my words, and please shoot me down. Exactly.
No, it's a very good description. It's a good way of putting it. So... and also, if the AI learns a skill, it very fast become superhuman. So
when do you think we will have a practical AGI then, potentially?
We will have something that can manage a more complex environment. Practical. We will have the ability to reason and do complex reasoning in 12 months if we get properly funded, and we can.
That would be amazing. If that's
So you have a good feeling about this now, but the proof is in the pudding. Of course.
And then I got this question: when can it write a PowerPoint?
Yeah.
The answer to that question is I can't really answer. I can't really set the date. It will be on my birthday, 20th of October, and it also. It's like this. You can always showcase. If I really wanted to make a PowerPoint, I can do the development in that direction, and we can have it by tomorrow. I'm exaggerating, but
it's your curricula. Would you put PowerPoint first in your curricula or not?
I think a lot of people would love it.
Actually, putting PowerPoint early in the curricula is good.
Yeah. No, the question is more how much can you accelerate this development from a baby AI to an adult AI, and we think it will be pretty fast, but it also depends on other resources like data and so forth. But
what's the bottleneck? Is it compute or is it the curricula?
There's with the bottleneck, the scarce resource. I would say we don't need that much compute as our peers in the business. So compared to them, that's not the bottleneck. About curriculum, we need training data, but since the system can train by itself, it's not could be a bottleneck, but not the same type of bottleneck again as those building humanoid robots.
So it is some kind of self-supervised learning, at least, if I'm trying to interpret what you just said.
Well, you can interpret if you want, but I won't help you labeling it really.
Okay.
I love this. It's so fun.
I'm trying to. Okay, I should stop interrogating you here. I think, but we're very curious. That's why we're asking.
Yeah, that's good. Yeah. I appreciate that.
Yeah.
But you had so many more great questions here, Anders.
Yeah. Okay. But
can I ask you, how would you define AGI or superintelligence?
Well, I think actually the Sam Altman one is rather good. Saying simply, when we have an AI system that can operate at a level that an average human coworker can, then we have AGI. ASI is something else, but AGI at least. So even just being able to take person whatever X in your company and actually putting an AI that does what he did. We are not there today for sure. But when we can, for a large variety of tasks, some tasks we actually can perhaps today, but for most tasks we cannot. And when we actually can that for most tasks, then we have AGI potential.
Yeah, and then it goes from doing it in the lab to do it in the real world, right? Yeah. So because Sam Altman, then maybe is Sam Altman's definition a physical one or a digital one? Or he has layered it even, right?
I think it works in both ways, but
Yeah, but the complexity potentially to do it in the physical world could be higher than to do it in the digital world.
Yes,
you need to stay in the real world, I think.
Yeah, I think
so again, we don't work in a lab. Okay, we made some early work, but we are in 2000. We started the company in 2022. In 2023, we had our first pilot customer. So the development has taken place in the messy real world without system integrations and stupid layout of the infrastructure, which is not optimal. You said before
you said before, maybe before the pod, that you really approached it with the first principles, and you said engineering mindset.
Yeah,
what did you mean with that? Is this physical real?
Yeah, so I stole a quote from Elon Musk. So we're more, rocket engineers than rocket scientists.
Yeah.
So it means like we have a problem. We try also to work with end-to-end systems and build the. If you want to build a rocket, you don't start with building a moon rocket. You start with a little firecracker or whatever, and then you build increasingly larger equipment, and then you can reach the moon. So we work in that way. So the easiest robot task, pick and place, narrow it down, and solve that first, and then more and more complexity along the way.
We have had this conversation for several years. What's the difference between science and engineering, and can you do research? Is it only science that is research, etc., etc.? And you are clearly in the Elon Musk camp here, like engineering, problem solving, rocket engineer, not rocket scientist.
Yeah. So in AI, it's interesting because the frontier between engineering and science is blurred, and a lot of what's going on in research institutions is actually engineering, and lots of what's going on in companies is research. And I would say that we said that we don't do research, we don't publish research papers, but what we're doing is probably at the frontier what's considered research. On the other hand, there are a lot of research going on, which is more probably research than engineering, and ultimately we're using research results from neuroscience, which is not, and physics, which is not related to computer science in a traditional way. So the research part is very important, and we rely on other people's research, but we don't do it ourselves in that way. Because there's a debate if research is dead or not. I would say definitely not. Research is very, very important. Yes. And Fermat's last theorem, that's research. It's not engineering. It's just fun mathematics.
Do you have a preferred definition of research and engineering?
Yeah.
Yeah.
Do you have?
I have one. Yeah.
Yeah, please.
So of course they're overlapping, as you say, but I think the big distinction is really the purpose. So the purpose of engineering is to build some product or create some real value in some sense. Building a Spotify app or a robot that actually do work. Like a product is the key. So the purpose of doing engineering is to build a product in some way that works and create value. But the product of science or research is to build knowledge, then I would say. So that means like publishing a paper or whatever, but it doesn't have to be published. The point is really that you do what's necessary to come up with an answer, some kind of new truth that you want to see.
Well, that's a good definition, actually.
Yeah. So then if you may have to do engineering to come up with new knowledge, meaning you have to perhaps build a prototype or something to see if it does work or not, because then you can answer a question, does it work or not? Then you create new knowledge. But if the purpose is really to build a product, then it's more engineering.
That's interesting because you used the description. You might need engineering to do research.
Yes,
yeah.
And you need research to do engineering.
Yeah.
It's blurred.
Yeah, it's blurred, definitely.
But it's very clear in the purpose. And I think what Elon is doing, and a lot of tech companies are doing is very, very clearly engineering, meaning they want to build a product.
Yeah, sure.
And then they do what's necessary to make that product work. Right?
Yeah.
So then it's clearly engineering first mindset, right?
Yeah.
And unfortunately in Europe, and I think a lot of research investments is clearly not, and that's a bit sad. I think.
It's actually both, because there's a lot of good research coming out of Europe that's very valuable and useful for engineers. So yeah.
Yes, but if you don't have the engineering, it doesn't really add value, right? So
that's a different story. Yeah.
So if you just have the research and do not have the engineering, then it doesn't really change society in that way, right?
Yeah.
I mean,
you need both.
And I think you need at least 10x more investments in engineering than you do in the research to actually come up with.
But on a macro geopolitical scale, this is a very interesting topic. Let's take the example of the AI Commission. Very, very brilliant people were highlighting what do we need to make Sweden better with AI. And we pinpointed, we need to have very, very strong research. Yes, of course, on that one. But there was one quite big missing gap in relation to that commission. And it didn't speak about engineering. It spoke about what we needed in terms of education. It spoken about more money. I mean, so you could really see who was sitting on the board writing the commission report was academics and senior leaders of big corporations. But the core fundamental engineering angle into that. And here we had, what was the guy heading up AI Science, AI Center in Rice, Sverker. Sverker said it so well when he was on the pod. You maybe know Sverker as well.
Yeah.
So Sverker said it beautifully. one of the key magics of Silicon Valley is that they have been schooling the best of the best engineers in computer science through the software industry, and they continue and do new startups.
Yeah.
So they build a real engineering ecosystem.
Yeah.
So, and if you search for that particular angle specifically in the AI Commission, it's actually a blind spot.
Yeah, I had the privilege to be advisor to a very small extent.
You see what I mean? Yeah.
Well, I was invited to a discussion, and then they showed the PowerPoint with these are the stakeholders. You have big companies, and then you have research, and then you have whatever, and startups weren't mentioned.
You saw my observation.
I comment on it as a lot of the development of AI is actually done in startups,
Yeah, of course.
more than in traditional companies. And this was exactly, as I said, a blind spot. Another blind spot in the AI Commission report is that it doesn't mention AGI. It may be in one sentence on one page. There was something mentioned.
Too far away.
Yeah, it's and I got the explanation of one of the people involved in writing the report that their mission was to provide the establishment with like low hanging fruits and not to complicate things too much and find out like a realistic roadmap for short term, something like that. So.
And just to not be too negative,
Yeah,
here, I think
we loved
still
it.
the work of the AI Commission was actually surprisingly
Yeah,
good.
it's a good step forward. It's a
Yeah. So
And also that the government actually later acted on it,
Yeah.
not to the extent they wanted
Yeah,
with 12
good one.
billion, but they actually did put up billions,
yeah.
to
So-
AI. So I think that's really, a big compliment
so
to the government as well.
so it's not misunderstood. It's a really good step forward, but
Yeah,
it was
sure.
just an interesting segue to how we discuss here engineering as the core.
And at least I was. They asked me the question and they asked for my advice. So
Yeah,
so
here.
yeah.
Cool. If we could, since I don't want to feel bad about trying to interrogate you more about your
No
system,
problem.
let's
No problem.
think about some other systems then, and connected to the physics and robots and real world AI and Elon. And if we take autonomous cars, autonomous driving, and now Tesla is doing the test beds with the robot taxis and everything in Austin, and trying to build that out. And he also speaks a bit about the difference. We have the Optimus bot, that is supposed to be like properly autonomous, meaning it's not teleoperated, but actually makes decisions properly. I think you mentioned something about, please correct me, I don't recall exactly, but I think you said something about it is so much more difficult to do proper autonomous robots than just having teleoperated, like human mimicry with a robot, right? I mean, just having what Boston Dynamics did, which was basically the body of a robot but not the brain. Now, actually, in the CES, they actually did add Gemini to Boston Dynamics and actually did get a brain as well. But still, I hope you see the point here. It is so easy to have a robot that you teleoperate, but that's not really what we want and need. We need proper autonomous decision making, right?
Yeah, sure, yeah.
And that's much harder, right? Would you agree?
Yeah, sure, yeah.
Yeah, it's kind of obvious, perhaps.
Yeah, it's obvious.
But maybe picking it apart, because for you it's obvious. Is it that it's like we've solved problems before, but in a certain way, and that doesn't scale, or actually doesn't have the three things together.
Yeah.
But doing it with proper autonomous decision making, all that is actually about fundamentally solving the three problems smartly. Is that a key?
If you have this is the requirements of industry. So if you have that, then industry will trust you and will implement the humanoid robots or whatever you like.
But what do you think about the current robotaxi kind of, and autonomous driving approaches? And they all try to scale that, and Waymo has their way to build it. China is really progressing super fast here as well. Of course, Elon and Tesla is doing that as well. Do you think their approach will work, or do you think they should? I guess you think they should use your approach, but still, do you think that can scale?
Yeah, I think they're doing good work. And if you compare it with pick and place, it's an easier problem because you're just moving the car. You're not moving it's one object all the time. To be fair, it's a much more complex environment than on the factory floor. So, but the proof is in the pudding. It appears to scale good enough.
So you think Elon in this year will have robotaxis in most cities, or do you think that will scale in that way?
Maybe. They talk about level 5 autonomous driving. I don't have the exact definition, but that could be hard, right? But in a fairly structured environment like a city, or where you also can cheat, so to speak, or have engineering solutions on other type of data and GPS data and so forth. So,
but if you take level 5, and one definition is simply the no wheel definition, meaning there is no steering wheel. You can't even take control as a human, right? And they do have, even built these kind of yellow robo-taxi things where you can't even, if you wanted to, control it, but you can
scary
remotely, right? So,
yeah.
I mean, even Waymo that has, several cities that's operated, they have remote control. So,
yeah.
Of course, it's driving normally autonomously, but as soon as some kind of problem occur, they have like a call center or whatever you should call it, that can take over at any time and drive the car. And I guess that's good to have that kind of fallback, right?
Yeah, the system deployed today is with the human in the loop, with the type of what do you say, lifeline.
Yeah. Okay, but it's interesting that Elon used the same term as you when it comes to real world AI, and he says basically to have full self-driving, you basically need AGI more or less.
Yeah, to really solve the problem, you need AGI. So you're back to navigation and pick and place and that thing. So yeah.
What do you think about the benchmark for AGI then? We have this kind of ARC AGI, 1, and now ARC AGI 2 and 3 is coming up with an interaction part of it. Are you familiar with these benchmarks, or have you?
Not by name, but what are the physical benchmarks, or what type of benchmark?
So ARC AGI is basically like a visual problem. So you see some kind of boxes on like a play board, and you should find a pattern, and then given 3 other boards, you should decide what the 4th one should be, and things like that. So like a visual kind of intelligence test.
Yeah, so we're in general not that fond of that type of benchmark, because again, an IQ test, if you put an IQ test in front of a 2-year-old, he or she will fail. So you need some other type of it's more related to actual skills, if you can solve skills with a certain type of complexity. So,
but this is a deeper, much more interesting question. What is a good way of benchmarking AGI or towards AGI?
Well, it's so, as Sam Altman, if you can do a wide range of tasks, and you can acquire them with a reasonable volume of training or time or whatever. So and how to measure it, I don't know. It's like, how do you know if a person is rich? How do you know if how do you measure wealth? Well, you measure it in money. But if you look at so money doesn't capture complexity. It's just a number.
It's just
It's just number. And if you look at Earth from space and you compare Earth with Mars or the Moon or whatever, then you can say, well, in some aspect the Earth is richer than Mars. Why? Because there's a level of complexity in the environment that you don't have at Mars, and there are there might be some sort of physical way of measuring. You can find measures for complexity.
Proxies, yeah.
Yeah. So a measurement of complexity in some way could indicate that you have a more intelligent system or something. And these benchmarks, they have simply too low complexity, and you can always, if you have a benchmark, you can always find a way to beat it by cheating.
You can optimize for the benchmark.
Yeah, exactly. It's like you can do in school if you're adapting to the system. So just what with the...
This is a hard question. It's a hard question to find a yardstick.
Yeah. And I think this low dimensional yardsticks, they don't really apply. You need to have some sort of complexity measure.
But it's interesting how that would be, I think part of stabilizing the whole industry and stabilizing things like that is to find yardsticks that we can agree upon is quite useful.
Yeah, it's useful, but it's like Siemens, the famous German physicist, says it. I think no, maybe not. It was someone else, maybe. Anyway, you get what you measure.
Yeah, exactly. I was going to go there.
Yeah. No, Siemens said, "Messen ist Wissen." So that's another quote.
I'd like to just hear what you think. We're going a bit more philosophical now and thinking about society and what will happen when AGI potentially do exist, and we will see changes happening throughout society. And something we're seeing already is that we have, of course, the big hyperscalers. They are the most valuable companies in the world, and they use AI and data to scale their business model, are very successful. Now, potentially, as AI increases faster and faster, we can also see the adoption of AI in normal companies not really following along at all. So even if we have exponential improvements in technology when it comes to AI, the adoption is linear in some sense. Do you see what I mean? Or?
Yeah.
So, even if you have amazing Claudebot or Multibot kind of things that you can use, it doesn't really change our society. It doesn't really change our companies that much, or even the people that much. And the reason for that is basically that the adoption doesn't happen. A few companies are very successful, of course. The hyperscalers are successful in adopting it, but most, even potentially according to MIT study, that 95% is not. So basically they're failing and don't get return on investment on any AI investment that they're doing. What do you think about this? Do you think that kind of, divide between the few that have succeeded and the rest of the world and the rest of the companies will continue to accelerate, or what do you think will happen as AGI is?
Yeah, sure. If you look at the adoption of internet, it was like things for universities, military. Now it's everywhere. It's generally adopted by my mother uses internet every day. Cell phones. Everybody has a smartphone, not a phone, but it's something else. It's a terminal, smartphone. So there is actually quite a heavy adoption of technology, and also this infrastructure for new technology, which the iPhone is. And the paradox with AI is like, well, everybody I know uses ChatGPT. That's AI. And the thing with AI is, when the AI gets more and more complicated and more sophisticated, there's another parallel development, that the interface towards the AI becomes more and more intuitive. For example, and this is the success of Lovable, for example, that you can vibe code, you can code without having this long education as a developer. So with this type of development with an interface that gets more and more easy to use, this will get the deployment of AI, or the use of AI will explode.
But still, what we see, if you take ChatGPT as an example, of course we see huge success then with OpenAI, and Lovable is another example of something that's gone really, really well, of course. But most companies is not on that way. So even if we have a few selected frontier AI labs that is extremely successful, but we can count it on one hand, more or less, most other companies fail, at least to gain the value. So the concentration of power, in some sense, as AI grow in capabilities, seems to be just increasing. And I guess that's a bad thing. Or would you agree with that? That we see the big frontier labs, but it's very few set of companies, and the rest is just trying to keep up, but they can't.
I think there will be some sort of democratization of the technology, and it will happen when AGI is established, because that's a different way of using data, and you don't need that heavy compute or whatever. You probably what will happen is that everybody will have like like this Claude again. You have your own data. You have something that's happening on your laptop,
But an argument against this is some people believe there is a first mover advantage here. So the insane investments we're seeing now, with hundreds of billions of dollars and even trillions. Even
That's great.
I mean, OpenAI has invested $1.4 trillion.
Yeah.
Even though having a revenue of like 20 billion or something. I mean, it's an insane amount of investment.
But let's untangle. I think there are two fundamental tangents here. On the one hand side, we have the growing divide of power of wealth, and we have then the AI divide between the ones who have a much higher invention, adoption, absorption capacity.
Yeah. There's two sides, two discussions.
So we have on the one hand side that fundamentals, and is that good or bad, or what happens when the few really cracks the code, and actually then not only crack the code, but they have the wits to absorb it into there. So this is one conversation. I think the other conversation, which you started on, where we have the exponential invention, but still a quite linear adoption capacity, has to do with that we are still not nailing down understanding what is important to train and shift and govern and set up. So it's not so much about the tech itself. If I look at the internet, it's the same way, right? So, okay, intuitive UX helps us to go to abundance faster. Then it became seamless faster. That was the sort of the pivotal moment in year 2000.
Yeah.
But then it took us 10, 15, 20 more years into architecturally and structurally get it into our operations of our big companies, right? And now it's e-commerce way bigger than we ever thought about it. So isn't that another part of the problem now, that if we want to be AI ready, so to speak, we need to continuously work on the fundamental patterns, how we organize companies that are AI and digital at the core, that moves at a different speed, that looks at mandates and decision making and agency. I mean, like, we haven't solved agency for humans yet, and that will slow us down for realized AGI.
Yeah. This is another discussion about large companies, and a company. There's a big difference between a large company that's been around for a while and a startup.
Yeah.
And you can actually look at the company as an organism that has a life, where the startup company, the baby company, is just consuming resources without doing any value. And then when the baby company is grown to scale up, then you have a shift in organization and shift in priorities, and you need to add lots of structure in the company to make it work and stabilize the company. And this is like the company is like a teenager resisting this change. And then you have an adult company that works well, that's a cash cow and has a stable relation to its market. But then the company starts to get old, and there's legacy and there's bureaucracy and there's a hierarchy level. This has happened to Google lately before there's been a shift. So and it's a challenge with this old rigid company to make it more agile again. So
but this
is preventing all type of change.
Yes.
It could be AI, it could be whatever. Yep. So this is another fundamental problem. So
but if we get back to the question of the first mover advantage, and let me try to phrase it properly here, because you said something similar or very positive, and I wish it really will become true, and that is that AGI will be democratized in some way. But I think a lot of companies do not believe that, and I think a lot of countries do not believe that. And I think that's the reason we're seeing these extreme investments that we're seeing, like hundreds of billions of dollars being spent, like the size of the Swedish GDP is now being spent by single companies even. So, what do you think here? Because one motivation for the first mover advantage is that once a company do have an AI that is smarter than the average human, they can simply scale it up easily, and then they will have they will have access to intelligence and capabilities that no other company or country will have. Hence, they will have a first mover advantage. And then the rest will just continuously be further and further behind. So, you could think like that, right? Or do you think it's wrong, or what's wrong with that kind of thinking? I hope it's wrong.
Yeah,
It's super scary.
that's one scenario, if you can't predict the future, and if you want to predict the future, that's a classical quote. So, and that's what that's one of the main missions with the company. So, if we are making AGI, making it work, then we can.
You can have a first mover advantage.
But we can also, and since our company is supported by the European Union, the European Investment Bank is considering investing in the company, so there will be like a joint. There will be Europe will be a shareholder of the company, and I think for us that's a good thing.
But are you afraid about the current kind of investment we're seeing? I think there will be backlash on this. I don't think they will get money back, from $1.4 trillion investments, in a couple of years of depreciation that they only have. So I'm almost hoping for a backlash, but still, some people, they probably have super smart people that thought a lot about this and do believe that there is a big first mover advantage here when they get AGI.
If you look at these big 5 tech companies in the United States, Facebook or whatever, they have, I think Facebook had like $1 trillion valuation. NVIDIA also, but NVIDIA is different because they have actually hardware. But Facebook, who could see that coming? And it's been that level of valuation for years. So if Facebook can keep up and deliver at par with that type of valuation, then there's nothing that says that OpenAI won't do it. And with some, if they add like ads in the feed, maybe that's a good idea.
But now John LeCun has left Meta, so now now will it go?
But I think there's another question here on that you put up, Anders, that I think is a nice sort of segue or bigger picture question, and that's sort of then what do we speculate, or the trajectory of the AI ecosystem? I mean, like, so, because if we think about several superpowers or geopolitical superpowers has defined this first mover advantage as a strategic topic, and we are now seeing USA, China, and we are now seeing even Europe waking up.
We have to be first. We're working on it.
We want to be first. We have to be first. We need to understand this, and we need to have our own the sovereignty topic or the cultural. There's so many dimensions, right? So, but what is your prediction? Is this going to grow as one AI ecosystem, or are we actually already fragmenting it in 2 or 3? Because the latest is almost like it looks like 3 paths: US path, European path, Chinese path.
I'll quote my grandfather. In Arabic, it's كل من في الوجود يتبع صيدا غير أن الشباك مختلفات, and it means that everyone is chasing a prey, but the means of hunting are different. So there are probably many ways to achieve AGI-like technology, and it will not be like one winner takes it all. It would be like a fragmented set of solutions.
But it is important that Europe has its own view and stake and push in this.
I think it's utterly important. So I was invited to Brussels to the committee, and it was me, and it was Mistral, and the founder of Legora, and one of the founders of Silo AI.
Peter.
Yeah, and we got a few minutes to give our view about the development in AI. And my point is, because Europe is competing with the United States and China, and so I said, stop copying the United States. Stop copying the United States. Make it a disrupting AI and take the lead that way. And this is
figure out your path. I mean, like, so we've talked about this on this pod. Sorry for jumping in, because also, what is it for us to be competitive, and what is it for us to succeed?
Yeah.
Why would we ever look at USA or someone else? Because they have a fundamentally one monolithic market. We have something completely different. So all those things highlight what's our strength, what are we good at, what are we going to use it for? All these things, if you don't answer those fundamental questions, then what are you chasing?
Yeah, and if you don't innovate, so my friends, colleagues, they're just doing more of the same, large language models, reinforcement, or whatever, and you can still do amazing companies with it, but it's not the disrupt that will put Europe on the map and put us in pole position. So that was my message to the European
And then,
Union.
of course, what is the disruption and on what abstraction level do you need to build it? This is another deep question, because maybe we can be disruptive, but we don't need to do everything ourselves. We can use other ones' technologies. I mean, like if you have the core technology disrupted at the core, the fundamental architecture, that would be fantastic. But we can also be disruptive without doing we don't need to copy from the lowest pattern either.
Yeah, of course, yeah. But most of all, Europe needs brave VCs, and there are a lot of money available for investment. There's like 100 trillion euros in pension funds. If you take like a small fraction of this, and instead of just feeding a lot of money to these equity funds. Take a part of it and make it more diverse in investment in startups and in technology, and you will have a fantastic growth in Europe, both in terms of money, in terms of company, in terms of technology.
Are we seeing this? Sorry. Yeah. Is this the trajectory we're seeing, or are we seeing something else? Are you hopeful that we're going in the right direction here? What you're describing, as I fully agree with you, by the way.
It is, the thing is, if you want it to run in the right direction, you have to put an effort into it yourself, and if you don't do it, then you have to take some responsibility in that. Yeah. And even if you do a little part, you're fine. But if you're just watching and complaining, you can always find you can always have some filter and looking at the development and think that this is the wrong direction or whatever. But
yeah, I love that you walk the walk, so to speak, and just don't do the talk, but actually try to be the disruptor. So it's so awesome, and I wish I could dig deeper in what you're doing. But
yeah, hopefully we'll be able to do that later. I look forward to that. So.
Yeah, I mean, like, and we you know that you need to go out and have some beers with some of his friends and find out the back door, maybe.
Should do that.
I was joking.
But Karim, to end off here and go even more philosophical, we've spoken about AGI a lot, and you believe it can happen really, really quickly, potentially, which would be fun, I guess. And
that would be great fun.
Yeah. Okay, but then will it be fun or not? So one way to think about this is to look at like two extremes. You know, one in the worst case, it could be the dystopian kind of nightmare where AI will kill us all, and we'll have the Matrix and the Terminator kind of future where machines try to kill us all. Or it could be the opposite, the super positive utopian future where we have AI that can solve cancer and fix climate crisis and energy and basically make the cost of goods and services go to zero, and we live in a world of abundance.
Yeah, that's the right way to do it.
Where do you think we'll end up? We probably won't end up like in the extremes, but where do you think we will end up potentially?
Well, if you look at the word in general, intelligence is not the problem. Stupidity is the problem. So that's a short answer. That's a short answer. Another answer
we should be scared of stupidity, and we should be scared of what stupid people are doing before we even reach AGI.
Yeah. And another way of putting it, Nobel Prize winners aren't usually the serial killers and the people, the violent, dangerous people in the world. So I think there's some sort of correlation between intelligence and good ethics.
Interesting one. We've been on to that. Why would the AI be benevolent or
benevolent?
Yeah. Why do we think a more higher intelligence being would be evil?
Yeah.
Well, but then you can argue with the wrong objective functions. But for me, that's a path. Those kind of problems. Is AI gone rogue that potentially is not even proper ASI or AGI?
Probably not. And if we circle back to this discussion about how do you measure intelligence, and I had some sort of idea that it's related to complexity. So I would believe that a highly intelligent being or machine or whatever will value complexity in a different way that we do. So, for example, the jungle, the most complex system in the world, is much more valuable than the petroleum oil, for example, in that context. That will put different type of priorities. For example, the concern of nature will be probably more important for a superintelligence than the hunt for energy or oil. Or if energy is important, then the superintelligence will make an effort to solve the fusion energy.
No, but the only problem is then when the superintelligence looks at the complex system and we are used to ants, and the ants is the problem.
Yeah, I would say that we significantly in that context add to the complexity of this Earth ecosystem. So I don't think the superintelligence will draw that conclusion actually that we're ants.
No. Anyway,
I love that you actually do try to be the contributor to the positive future and be the disruptor, be the one that actually drives perhaps Swedish and European AI forward, and have such a positive view. That's really, really inspiring, I think. So thank you so much, Karim, for coming here and talking with us.
Super exciting.
Yes, thank you very much. I really enjoyed it. I look forward to this pod actually since we spoke again. So really, really interesting discussion, and really nice to meet you also. It was really fun.
So much fun. Thank you.
Thanks.